Hello friends, in the current video tutorial, I will be teaching how to simulate signals in LabVIEW. We are going to simulate signals such as sine, square, triangular, sawtooth using Simulate Signal Express VI in LabVIEW. We shall also be studying how to change the frequency, phase and magnitude of the simulate signal. Apart from this, we will also see how to add noise to the signal. So let's see how we are going to generate it. So there is this Express VI toolbox and you have this simulate signal. So you just place it on the block diagram. Now this pop-up window pops up and you can select various options such as sine, square, triangular, sawtooth, DC. So let's select sine first, and you can also add noise, but at present we will just proceed without the noise, and you can put samples per second, number of samples and all that, and you can also select integral number of samples, and you can select the absolute date time or relative time. Let's first go with the relative time and just press OK. So this Express VI is ready. Now we have to wire amplitude, write the amplitude. Then wire frequency. And then wire the offset. This. So these things are ready. Now let's wire them. Let's add a waveform graph to see the display, how the signal is generated, and finally we must add a while loop for this. Let's create a stop button. Let's place the stop button here. Let's now run the VI. So at present amplitude is 0, frequency is 0, so the displayed line is flat. Let's increase the amplitude. Amplitude is increased but the frequency is 0, so nothing will be displayed. Let's increase the frequency. As I increase the frequency, when the integral number of cycles, as in the oscilloscope case, will come, then the frequency, the signal will be displayed as a stable signal. So 5.1 I can try. little bit shaky. So at 10 it displays the integrals cycle integral. So let's now add some noise to the signal. For that you just again open this pop-up window using you can open the pop-up window by double clicking on the Express VI, or you can select properties and you have this Sine. You can add noise to it. You can add uniform white noise. You can add Gaussian white noise, periodic random noise, gamma noise, Poisson noise, binomial noise, Bernoulli noise, MLS sequence, inverse F noise. So let's first select the uniform white noise and noise amplitude is 0.6. So you can select noise amplitude from here. You can wire an input to it, or you can leave it. So let's run it now. So you see that noise is added. If I reduce amplitude, only noise signal is there. Yes, amplitude is for the signal and 0.6 is the amplitude of the noise. So if I increase the signal, there is considerable noise which is displayed. As I increase the signal amplitude, the noise displayed is less and less. Little bit noise, but as I decrease the amplitude of the signal, the noise becomes more and more. Now let's see other things. Let's first remove the noise. Now let's see if the signal generator is okay. So this is fine. This is a sinusoidal signal. Now let's change the offset of the signal. So if I change the offset of the signal, you see that the signal has not started from 0, it has started from 2. So you can change the offset of the signal, and then you can also change the phase of the signal. Let's generate cosine signal instead of sine signal. So this is cosine signal, and because I have changed the phase, and you know that cosine signal and sine signals are 90 degree out of phase with one another. So what happens if I change the phase to 180 degree? If I change the phase to 180 degree, so this is an inverted sine signal. So you can use this attribute of the Express VI to change the phase of the signal, and you can generate sine and cosine. Let's see we can generate other signals also or not. Now let's select sphere wave, and for that we have to put a duty cycle also. We can wire and put over here at percentage. absolutely 50%. So 50% of the time the signal would be high and 50% of the time the signal would be low. So let's make the amplitude 0 first. Because the amplitude is 0, so output is 0. That increases the amplitude. So in this way we can generate signal. Let's increase the frequency. Let's make it 20. So there are two waves. Let's make it 100. So there are 10 waves. So this way you can generate a clear signal. Let's use the amplitude to 0. And let's decrease the frequency to 10. Let's now generate another signal. This is triangular signal. So you have to remove this duty cycle. Let's generate the triangular signal. So this is the triangular signal generated. You can increase the frequency just like the previous case. Say 100. So this is triangular signal frequency. Let's say 5. Sorry, 50. So there are 5 triangular waves now. Let's generate now Sawtooth wave. So this is a Sawtooth wave. Let's decrease the frequency to, let's say, 10, which will give a more precise Sawtooth wave. So this is a Sawtooth wave. Let's see what else we can do into this VI. We can also generate DC signal. If I generate a DC signal, so amplitude is 0. There is no option for amplitude, there is only offset. So you can increase the offset. So as I increase the offset, so it moves up. So let's see some other things. Back to sinusoidal signal, and you can select the integral number of cycles. It will give the actual number of samples and actual number of acquisitions. And you can run simulated acquisition timing. You can also wire absolute date and time to the signal. So you can see that this date and time are being displayed in the real time. So this is all about simulating signal using Express VI simulate signal Express VI using LabVIEW. Thanks for watching this video. I hope you have liked this video.